Hello and welcome back for another VMK in the game development series. In this VMK, we're going to be creating the class that stores all the shader information from the Caligari files. As you've seen in the previous couple VMKs, we've already created this Caligari file class which parses the Caligari file, and then as it's parsing it, it's saving data to three different kinds of classes. In the previous VMK, we've already discussed how to save all the material data. We still have yet to write the class for the poly H, but in this VMK, what we're going to do is create the class that saves all this shader data here. So it's called CaligariShBx. So to start off, we're going to do the same thing we did in the previous VMK, where we're going to go into the object library and create two new files, a CPP file, and a .h file. Okay, starting off with the .h file. At the top, we include core.h, and then we have our class called CaligariShBx. We have a constructor and a destructor. Constructor accepts the same parameters that our previous Caligari Material 1 class saved. Our destructor is going to do a little bit more work than our Material 1, and I'll get to that in a second. We have a function here called saveParameter, and this function is similar to our, what was it called? It was back here inside of our parser. It's something like find keyword. You remember that we had a function here that accepted a type and a void pointer. And then depending on what the type was, we knew what kind of data was being accepted into this last parameter here. Well, this save parameter has a similar structure where we have a type and then a void pointer at the end. And in a second you'll see how this works. But the general idea is we're going to pass in a bunch of parameters into here to specify here's some data that we may want to save. If the checks pass and we do want to save all this data, then the data we want to save will be stored inside of this parameter here. So because we have the type and the parameter name and all this other information, we'll know exactly what this data refers to, and then we'll know which member variables we need to save this data inside. Now, talking about our member variables, we have a constant long value for our ID number as well as our parent ID number. We have our emissive value, our diffuse value, shininess, and specular color. You'll notice that emissive and diffuse are floating point numbers rather than an array of floating point numbers. We have to handle this appropriately inside of our code because inside OpenGL we're going to be expecting to have these as an array. However, Caligari only saves these as a single value. And I'll talk about how we're going to handle this a little bit later, but just be aware that right now these are just floating point numbers, not arrays, so it's okay that that's the case. We have a boolean here which we're going to indicate whether this is a solid object or not. So depending on the alpha value, if we are using transparencies, then the object will not be solid, so we have to check this off to be false. Otherwise, by default, we're going to set it to be true so that we don't do any blending whenever we're rendering this object. We also have a couple parameters here that are strictly used by the texture transform. But everything is stored inside of this Caligari shader because that's where the Caligari file format saves the information. So we have S and T repeat and S and T offset. You'll see how we use these in the transform for the texture a little bit later. And then the last thing we have here is a pointer to a character string, and this pointer will contain the file name that we want to load in to texture our object. This is also going to cause us a little bit of trouble, so let me talk about it once I get into the CPP file. Alright, so let's go into CPP. At the top we have our standard includes, and then we have our constructor here. Again, because these two variables are constant, we need to use this colon notation and pass in the values into our constant variables like so. Then you'll notice that the bracket comes in after that, and then we have our initializations for all of our other member variables. So we set emissive equal to 0, diffuse set equal to 1, shininess to 0, specular color we set it to black, and then we have no texture file name yet, so we set this to null. And then we have repeat set to 1, meaning if we are going to be using a texture, then we just want it to show up once for an instance of a face. We don't want to have it repeat more than once per face. Our offset is going to be 0, 0, so that it's perfectly aligned with the bottom left-hand corner of a face. And then we also set here the solid value to be true. Our destructor has to take care of some dynamic memory. You'll notice that because we have a pointer to a file here, initially we set this to null, so when the destructor comes around we call save delete array, and if it's null then this doesn't do anything. However, later on, if we do assign a name for this texture, then we do need to clean up the memory, so we use save delete array to make sure we call the delete on this member variable, so that we do clean up any memory that was allocated using the new operator. Alright, and the last function is the save parameter. Now this is a little bit tricky, so what I'm going to do is I'm going to go into TrueSpace and play around for a little bit so I can show you specifically what we're looking for inside of this function called save parameter. So back in here, what I've done is I've created a sphere and I've colored it. And I've chosen sort of a brownish color here, and I've also set some values here for the luminance, diffuse, shininess, and specular color. I've taken this file and I've saved it out to be called shape.cob, and I've saved it in a location where I can go and run our CaligariParser.exe file, which will then parse that file. Doing this, you can see we have all of our data, and if we're just interested in the shader data, so let's take a look here. Inside here, we have our shader class color, and inside the color part, we have the shader name is plain, the number of parameters is 1, and then the first parameter, which is ID 0, is called color, C-O-L-O-U-R, and then the actual value is this 3 values right here, red, green, and blue. However, when we look back inside of TrueSpace, these numbers are really this color right here. You just have to click on the little arrow up here and you'll see numerical values for the specific color. You'll notice I chose strategic numbers, 200, 150. And these numbers don't really show up inside here. Instead, we get decimal values. The reason for this is because Caligari format is normalizing these values to be between 0 and 1. So a value of 255 is equal to 1, and the value of 0 is obviously equal to 0. So if I were to take this number here and set this to 255, apply that material to this color here, resave it, and then rerun our program, you'll notice that the first parameter now is set to 1. And then the second one is actually 100 divided by 255, which is 0.392157, and so on. And the last one is 50 divided by 255. So that's where these numbers here come from. Then we have the reflectance shader. So you notice here we have the shader reflectance, we have the shader name is called fawn, and it has 5 parameters. Parameter number 0, so this is the first parameter, is called ambient factor. And the ambient factor right now is set to 0.1. Well, looking over here, where is this 0.1 number coming from? If you right-click on any of these swatches here, you'll get numerical representations. And here you go, here's the 0.1 that we see, which to us is really the emissive factor, is represented as 0.1. So going back here, ambient factor, something called ambient factor is actually the emissive factor for us. So we need to take note of this, because when we save it inside of the function, we need to make sure that something called ambient factor is going to be saved into the parameter that we've called emissive. The next guy down here is diffuse, and you'll notice that the parameter down here is called diffuse factor. So if I change the diffuse value here, whatever it is, then basically I'm changing this parameter here. Next one down is shininess, and shininess is actually saved as specular factor. So anytime we're referring to the shininess value, we should be looking for something called specular factor. So you notice that the name notation here is not the same as inside of the Caligari format. You have to be very careful whenever we're parsing, because we can only identify numbers that we're getting by these names here. Then we have something called exponent. But as I was playing around with this, I couldn't get this value to change. It was always 13.79999 and so on. I don't know what this is, and we're not going to use it. We do need to have an exponent value, but we're going to use the shininess thing here to give us the exponent to use inside OpenGL. So don't worry about this exponent factor here. It's just another parameter that gets saved with the Phong shader, but we're not going to worry about it. The last parameter inside the Phong reflectance shader is a specular color. And right now it's set to 111, which is this color right here, which is white. And again, if you wanted to have numerical values for these, just right-click on this little swatch here, and you'll get another window that pops up. And by changing these values here, you can give different numbers down inside of our Caligari format. So for instance, if I change these all to 128, actually I'll do this. I'll change them to sort of this yellowy color. 128, 128, and 0. Now I apply this color to our material. Can't really see a difference. Go and save this guy. And now reparse our file. You'll notice I have basically 0.5, 0.5, and 0. So 128 divided by 255 is about 0.5, 0.5, and then this is 0. So that's where these numbers here are coming from. They're basically going into the specular factor color. So this is what we're going to be looking for. Let's go into Visual Studio now and take a look at the save parameter guy. What we do is we're going to be saving, let's see here. Let's open up our shader guy. We have to save these values here that we just created member variables for. So the first guy is the color for the texture map, which I haven't talked about, so I'm just going to close this off for now. Let's talk about the reflectance shader first. First thing we do is we look at the shader name. If the shader name is Phong, then we know we're going to be getting these 5 parameters here. And then depending on which of these 5 parameters is being sent to our function, we need to save the appropriate value into the appropriate member variable here. So if it's something called ambient factor, well, ambient factor was this first parameter, which you'll remember was associated with the luminance here. And the luminance is actually the emissive value. So you'll notice that I'm taking the value that gets passed in here, which is p-value, casting it to a float because I know it's type 3, and I'm taking the value of that guy and saving it into our emissive variable. So that's what that's doing right there. Then we have diffuse factor. Again, going back here, diffuse factor was the second guy, which happened to be the diffuse color here. So with that, it's pretty obvious that we should be saving it into the diffuse member variable. It's also a float here because it's type 3. Next, we have specular factor. And remember, we had specular factor here, which was associated with the shininess value here. You'll notice as I'm cranking this around, the shininess on the sphere here is changing. It's getting more shiny or less shiny. So we're going to use that as a shininess value, so it gets saved inside of our shininess parameter here. Then we also have specular color, and specular color is type 7, which means it's red, green, and blue. So we cast our input value to be a pointer to a float, and then we just use the red, green, and blue and save it inside the specular colors red, green, and blue parameters here. Alright, so that's how we handle the Phong shaders. Now, we also have another shader called matte. Let me show you how to use that. If we go back into TrueSpace, by default, when you open up the material palette, you'll have a Phong shader selected. But you don't have to use a Phong shader. You can right-click on this guy, and you have a bunch of different shaders you can choose from, similar to how we chose the texture map for the color guide down here. Well, instead of using the Phong, which is located right here, you can move down to Matte, which is located over here. And if you click on this, you'll notice now we only have luminance and diffuse values to play around with. Specular color doesn't play a role. If you right-click on this, you see you have luminance and diffuse, and you can play around with these values as much as you like. So if we're going to go and save this now, actually first I have to apply it. So let me just apply that color to our sphere, resave our file, and then let's go and parse it. Okay, now you see we have shader name called matte, and it has two parameters, ambient factor and diffuse factor. So you see ambient factor 0.2, 0.2, and diffuse is 1, so it's 1 right here. So those parameters match up. Well, ambient factor is really our emissive value, so just be aware of that again. Inside of our code, if we're looking at matte now, then if we find something called ambient factor, then we save that inside the emissive, and if it's diffuse factor, then we save that in diffuse. But now we also have to handle the case of what do we do with our specular color and our shininess. Well, by default, inside of our constructor, we've set the specular color to be 0 and shininess to 0. So we really should be safe. But I like to play safe anyway, and down here, right after the check here for whether it's this guy or this guy, I always set the shininess and the specular color always to be 0. So this way I know for sure that the shininess and specular color will always be 0 no matter what, if we're choosing a matte shader. Okay, so that's the way we handle the reflectance. Now onto the textures. With a texture map, if we apply it onto an object, we have to save certain parameters. So first thing we're going to do is go back into TrueSpace and apply a texture to an object. So let's just pick an easier object to work with, like a plane maybe. And let's just reset all these values so it's gray. And I'm going to go in here and just apply the default texture, and I don't know, let's see, maybe this fish over here. Okay, so I have a fish texture that I'm applying to a plane here. Now let's go and save this. And let's parse it. Now let's take a look here. Under the color section for our shader, we have something called Caligari texture, and it has 7 parameters. First parameter is called name, or actually it's called file name with a space in between, and the name is the path to where this texture is located. And now notice something interesting. The path itself is absolute, which means if we were to use this inside of our game engine, it would be no good, because as soon as you compile your code, give it to a friend to run on their computer, guess what? This texture will most likely not exist on their computer under C:TrueSpace66/textures. So because of that, what we have to do is we have to be a little bit smart here. We know that the texture is called 3dfish2.tga. That's good. However, all this path information, we have to get rid of this before we save it inside of our class, because it's really useless to us because the file itself could be located anywhere. And we're going to follow sort of a strict format to where texture should be located when they're associated with Caligari files. And the rule that we're going to use is this. If an object is going to be using a texture, the texture has to be in the same directory where the Caligari file is located. So for instance, if I create some sort of mech, and I call it mech.cob, and I save it, wherever I save that, that's the same directory where the textures have to reside. Because of this, whenever we're loading in cob files, we will have the directory for that cob file. We can then go in and associate that directory with any file that we read in from the Caligari file to be able to find the texture. We can change the rules if you want. So for instance, maybe you want to say wherever the COB file is located, we want to place the textures into a separate folder offset from the current location. That's fine too. But just to stay simple, I've decided all textures have to be in the same directory where the COB files are going to be located. Okay, then we have our sRepeat parameter, we have tRepeat, sOffset, tOffset, and then we have something called animate and filter. And those parameters are basically associated with these two checkboxes here. I'm not quite sure why this one checkbox here doesn't get saved into the file, but it just doesn't, so we're not going to worry about it. So now let's go and take a look inside of the code here. How do we handle this Caligari texture stuff? Well, first thing we do is we need to go and get the file name for this texture. So if it's the file name that we're looking at, so if the parameter that gets passed in here is called file name, and it's of type 10, so that tells us it's a string, then what I do is I go through the string that gets passed into us, and I look for the very last slash. So inside here, I'm looking for this slash here. If this slash doesn't exist, then that means that the name that gets passed in here for the file name is already at the local directory. There is no extra path information. However, if there is a slash, then I basically want to find where the slash is, move forward one so that I'm pointing at this location here to the beginning of the file name, and then take all the information for the file name and use it inside of our class. So that's what I do here. I look for the slash. If I find it, then I move one past the slash forward in terms of where I'm pointing, and then I go and find out exactly how long do I need for this file name to be saved in memory. So I allocate new memory, and then I go and use the sprintf operator to save the value inside this member variable. If there is no slash, then the entire string is what I want, so I just use the entire strings pointer, pass it into this p slash here, and then I repeat the same process here. I get the length of the file name, allocate new memory, and then save it inside of our member variable. So that's the way we handle the file name. Now we have sRepeat. That gets saved into a member variable called m_fsRepeat. We have tRepeat, sOffset, and tOffset. That handles all those parameters. Now there's only one thing left, and that's this parameter right over here, bSolid. Remember, this was an optional parameter that the user, or I guess the developer, needs to specify whether a texture that they're using is going to be transparent or not. So if a texture that you're using has an alpha channel associated with it, you have to tell the game engine that that's the case, so that the game engine will turn on blending so that the alpha channel is calculated whenever we render things to the screen. So to handle that, I went back into TrueSpace and I said, okay, well, what can I use in here that will be basically a trigger on-off that says, yes, I am using an alpha channel? So what I did is I said, okay, let's use this parameter here. I have a checkbox which I can turn on and off, and by clicking it, it doesn't really change very much in terms of what I see here in the render window. So let's just say that this parameter, whatever it is, according to the status bar it says use filtering for textures in high rendering mode. I don't know what that means, but for me, what this is going to mean is as soon as I check this, this means I am using an alpha channel inside of my texture. So I can then go and save this information because I have it inside of the file here. And as a matter of fact, this checkbox is associated with this parameter here called filter. So if that's the case, we'll scroll down here and take a look. So if I have filter and it's of type 6, and type 6 is basically a Boolean because the value is of type Boolean, then I take the value and I check to see if it's greater than 0.5. So if it's 1, which is greater than 0.5, then that means, yes, I am using a texture that has an alpha channel, which means, no, it's not solid. So that's why we set it to false. If it's less than 0.5, then we set this parameter here to be true. So I'm using negative logic here according to what I want this variable here to be set at, true or false. And that's basically it. So this is how we handle everything that gets passed into us for the parameters here for for the color associated with the texture, as well as for the Phong and the matte that are associated with the reflectance. Okay, let's go and build this, or actually compile it. Don't build, because if you try building, you'll get a whole bunch of error messages because we still haven't implemented the poly-H class, which is the next one coming up. So if you try building, this is what you'll get. You'll get fatal errors saying, oh, actually we have some other error messages here, but basically cannot find poly-H.H yet, so you can't build your project. But since we have these other error messages, let's go clean them up. Cannot include triangle.h. You'll remember that a couple videos back we removed triangle.h as well as house.h from our project. So we no longer need these two. Let's go and just delete them so that we don't get any compiler errors. And there's a couple others down here. Let's see. Maybe that was it. Cannot include house. Let's delete that. Cannot include this guy because we haven't written it yet. Okay. All right. We're also getting these other error messages. Caligari file undeclared identifier inside scene.cpp. And that's because inside scene.h we forgot to include Caligari file, which was excuse me, which was this class right here. So let's save that, and oh, my toolbars are moving around on me here. Let's go build this. Okay, cannot open this, that's fine. Cannot open that, that's fine. Alright, so that's basically it. We can't build yet because we need to fill in the one other missing piece, which is the Caligari poly-H class, which is coming up in the next video. So that's it for now. Come back for the next video where we're going to fill in the missing piece.